right, so today we're going to be looking at a few examples going over our function notation and evaluating our functions. So, number one, what is the definition of a function? I've asked you guys that so many times at this point. Okay, so I want you to go ahead and take a second to type the definition of a function now. All right, I hope you took this few minutes to type out the definition of a function. It was on the back side of this page, so you could have easily flipped your page over and typed it up. Okay, so the definition of a function, in case we forgot, is a relation where each input has exactly, oops, if I can spell right, one output. All right, so a relation where each input has exactly one output. So today we looked at function notation and we're evaluating functions. We already know that these functions are special because each input does have one output. Okay, that's the point of function notation. It tells you, hey, this is a function. You don't need to check it. I'm already telling you it is. Okay, so we can actually go through and evaluate these functions and get some important pieces of information. So looking at this, it says evaluate the function f of x equals x squared minus 2 at x is equal to negative 3. So I'm going to take that negative 3. This is my input. Okay, remember x's are our inputs. They're also our domain. And I'm going to put that into the function. That's why we call it inputs, because we put those into the function. Okay, so when I do that, instead of f of x, my x isn't x anymore. Now it's a negative 3. I'll have negative 3 equals, instead of x squared, it'll be negative 3 squared minus 2. Well, negative 3 squared, we spent all that time working on exponents. We know that means negative 3 times negative 3 gives me 9 minus 2. Well, a 9 minus 2 gives me 7. So f of negative 3 is 7. Remember, I can write those as a coordinate point. Okay, so it's going to be negative 3, 7. All right. So we're going to do the same thing with the next one. It says evaluate the function f of x equals 2 to the x power, okay, at f of 1/2. Okay, so what I want everybody to do real quick though is this should not say 1/2. That was definitely a mistake on my part. Scroll that out and write negative 2. Okay, so it's actually, I'm just going to scribble the whole thing out. It's actually going to be f of negative 2. That's definitely my bad. I'm really sorry about that, guys. So I'm going to take this negative 2. That's the same as saying x is equal to negative 2. That's my input. So I'm going to put that into the function. So now I'll have f of negative 2 equals 2, and instead of an x, to the negative 2. Now, we spent all that time working on our exponents. So remember, if I have a negative exponent, that means I have to move it to the bottom. So it becomes 1 over 2 squared. And 2 squared just gives us 4. So 1 over 4. So I know that f of negative 2 is equal to 1/4. Okay, so I could write that as a coordinate point. My x was a negative 2. So I'll have negative 2, 1/4. And that's what I would graph on the table, or graph on the coordinate grid. Okay, so remember, this is just to find all the points of our function because we're going to eventually get to graphing those. So we're really just finding all of our points right now. All right, so speaking of points and graphing points, I've got example number 4. It says plot and label the following points. Okay, so for example, letter A is negative 2, 1. I'm going to go back to negative 2 and up to, here, I'm going to use my highlighter so you can actually see that. Okay, so I'm going to go back to negative 2 and up to 1. Okay, so that will give me the point negative 2, 1, which was A. All right, so I want you to go ahead and plot the rest of those. We just did A. So I want you to go ahead and plot the rest of those, and then you can check your work with mine when you're finished. All right, so I hope you took the time to plot those points. Okay, part B, we have the point 0, 3. So I stay at 0 and I go up to 3. So that's going to be point B. The next one was point C, and that was 4, 2. So I'm going to go over to 4 and up to 2, which was C. Point D was 1, 0. So I'm going to go over to 1, but then I don't go up or down since it's 0. So that's point D. And then point E, -5, -3. So I'm going to go back to -5 and down to 3. And that's going to be point E. All right, if you have questions about plotting points, please make sure you're asking. Okay, so I can help you out on that. All right, and then our very last one, last but not least, number 5 says determine if the following relation is a function and explain yes or no. So I want you to go ahead and look at this relation that we have right here. We've got this input and output table, okay? And then this relation tells us that 10 always goes to 8, 11 always goes to 8, 12 always goes to 8, and 13 always goes to 8. So I want you to pick yes or no, it's a function, and then we're going to talk about why. So go ahead and do that now for me. All right, so I hope you take the time to pick if it was a function or not. This actually is a function, this is. And this is because each of those inputs only goes to one thing. 10 only goes to 8. 11 only goes to 8. 12 only goes to 8, and 13 only goes to 8. Okay, so each input really only does have one output. Now, if 13 went to 10 or to 8 and to 10, that would have been bad. Okay, that would have been made this not a function. But since they all only go to one thing, we're good. So why? Because each input has exactly one output. All right, so at this point, you can move on to your homework, okay? And then you're good to go.